function, you were able to actually transfer something to another location. That's what's going on. Very good job.
We're only adding the points? Only the points? Oh, okay.
Okay, so I did something interesting today. I gave you a warm-up containing a concept that we have never explicitly discussed. Although, I feel strongly that you should have been able to figure out, to some degree at least, possibly entirely, what you were supposed to do. Let's get the result first and then we'll talk about it. What was your result for number 1? Give me the entire results. Start with John, Sharik, and then Kadir.
I got negative 6, 4, negative 1, 5, and 0, negative.
Okay, Sharik?
I got negative 6, 4, negative 1, 5, and 0, negative 4.
I think that was the same as his. Kadir?
Negative 6, 4, negative 1, 5, and 0,
That is correct. So I apologize that the instructions were a little misleading because it says find the image. What I meant, I copied that from something the publisher had written and I should have modified it. I was looking for the points, and I did say that partway through the work time. All right, so now number 2, what did you get? We'll start with Dayanara, Stephanie T, and then Alexander.
Negative 2, 1, negative 3, 5.
Okay? Okay?
I didn't know the second one wrong. I didn't read it right. I did Y first, and then
So you're saying that you're
I
wrong because of what they said.
No, I just cause I was seeing what they said, and I was like, it says negative Y, and then I ended up putting negative Y for the X's, and then,
Well, read to me what you put.
well, I know it's wrong. That's the thing.
But I don't know it's wrong, so go ahead and...
I went 2, 1, negative 3, 5, and 1, negative 4. Like,
Okay.
Yes. I was saying I knew it's wrong.
I don't care. I think you did wonderfully well, considering never explained this at all.
I knew it too, kind of.
Good. That's the most important thing. You're saying I knew what to do, kind of. That's very good. So the idea is you can use a function to translate one point to another. So what happens is this point translates to this point. I'm sorry, transforms to this point. I'm using the wrong word. Transforms to this point using this rule and that rule. And so what happens is when you use the rule for a bunch of points, all of the points are transferred the same way. This is called a transformation. And this is technically how you do a geographic transformation. Number 2 was a little bit harder. It was a little confusing how to interpret this and this. What this means is take the y value, flip its sign, and then put it as the x value. Take the y value, flip its sign, and then put it as the x value. Take the y value, flip its sign, and put it as the x value. That's what that says. This says, take the x value and put it as the y. Notice that the x and the y are the same. X, y, x, y. Anyone have any questions about that? Good. This is something you're going to start seeing periodically in class and periodically in the textbook. Are there any questions? No questions at all. So if I gave you another one at another point today or next week, you'd be okay. Good. Let's hit the pause button. And you have 4.2. You should have a slip at your desk. And so because of absences, we're going to have to rotate some people around. Oh, no, we won't have to. You two trade, you three trade, you two trade, you two trade, and you join them and trade with those two. Okay? Trade papers. Grade the person's work. Complete the slip. Staplers are being passed around. Let's go. Should be pretty quick and efficient.
Do you go to the bathroom?
He did something.
You play the camera.
No, she doesn't know dirty house. She good. Did you read?
You didn't read
You know if you got it right. You got it right. 9. You got a 90.
Wait.
Yeah?
Did you do your homework?
Yeah. Right at the bottom, right there. Oh. That's better more. Yeah.
I know, like, that's really we were so big.
Okay, you should be wrapping up. Draw a line across your paper. Absolutely. Thank you for asking.
Everyone's got one.
Not physically
I know. Kayla's
She was here.
She lost her phone. She lost her phone, so she called her mom from bed.
Wait, Kayla, that was Kayla's phone?
She also
You called Kayla's phone?
I know, It's in the bag. Always bad.
Oh my gosh.
You found your phone.
Wait, what
You got an
and the
eight
guy.
Leave it. Thanks.
You found a phone?
All right. So, staplers are going around, and I also gave you a small slip of paper that you're going to staple in eventually. You should also have your score. Here are today's objectives and vocabulary. You need to digest this for a moment. And while you digest that, I'm going to call your name and you tell me your score. Nathaniel.
She legit lost her. Like, we're going to lab. We're going to myself. And she's like looking at her back for her phone. I can't remember.
Okay, come on. Next goal. John. Giamara. Dianara. Kadir.
Eight.
Matthew. Stephanie T. Eric. Alexandra.
8.
Sharif.
9.
Nathaniel. John.
8.
Make sure I get your score before you leave, Nathaniel. You can just keep it, Adam. You can just keep it. Okay, today, 4.3, we're going to do transformations and how it relates to congruence. We've been, for 2 lessons already, talking about triangles, and we're going to go right back to talking about triangles next time I see you. In fact, 4.4 all the way to 4.9 is all about triangles. So this is a little bit of a side trip, although you'll understand the connection when we finish. Today's lesson is also going to be pretty short. There's only a few things that we need to touch on. I also handed out a slip of paper. That's going to be part of the lesson. You're going to need it in a little while. So, our objectives are to be able to describe transformations in a coordinate plane and use properties of something called rigid motions. We're going to talk about that. And so here's the vocabulary. Transformations, rigid motion, translations, reflections, rotations, and isometry. Some of these you should be familiar with already. So let's get right into the new material. Transformations is a way of changing a figure to another. There's a particular type of transformation called a rigid motion. A rigid motion is a transformation in which the length, angles, and area are all preserved. In other words, preserved means they stay the same. So it's transformed, meaning it's moved somehow, but the size and the shape are staying the same. Another word for rigid motion is isometry. When I took geometry over the summer, a lot of the more experienced geometry teachers used the word isometry. I was more comfortable with the idea of rigid motion. It just seemed to make more sense to me. But I want you to know the word because you might see it in the book, you might see it on a quiz, you might see it somewhere. You might see the word isometry. So what are rigid motions? 3 examples that we're going to be using. Translation, reflection, and rotation. Those are all examples of rigid motion. One little detail that you need to be aware of in addition to that. When we deal with transformations, you're talking about 2 pictures. They have names, and it's a little counterintuitive. The original figure is called the pre-image. The new figure is called the image. To me, when I learned that over the summer, that sounded strange to me. Because I would have thought it would be image and then post-image, right? The prefix post means after. So I don't know why someone decided it was supposed to be called the pre-image and then the image. But someone in the world of mathematics made the decision, and that's the convention. The original is called the pre-image, the resulting figure is the image. Any questions so far? Yes.
So isometry is just another word for rigid motion.
Exactly. Just another word for rigid motion. John? Okay. Now, the first example, we got some diagrams. Don't take out your ruler and start drawing perfect pictures. You can do a quick sketch because it's really the idea that you need to get across. So here we go. Congruent figures. That's the connection between what we talked about last time and what we're talking about today. Last time we talked about congruence being all the sides had to be the same and all the angles had to be the same. That's congruence. Now we're saying it a little bit differently. 2 figures are congruent if and only if one or more rigid motions could be used to transfer one figure onto the other. In other words, to get the pre-image onto the image, if you can use rigid motions, then it's congruent. So, translation, SL, a slide. This is the pre-image, that's the image. We could slide this on top of it and show that they're exactly the same. That's congruent. Here, we have 2 quadrilaterals. This one could be reflected over this axis and end up exactly on top of this one. If it ends up exactly on top of it, then it's congruent. We used a rigid motion, reflection, FL for flip. In this last example, we have this quadrilateral, a trapezoid, And if we can use a rigid motion to get this to end up exactly on top of this, then they're congruent. And we can use a rotation to accomplish that. You can also see what was intended by these little arrows indicating what was happening. Any questions about that? So that's the basics of what we're talking about. There's not a whole lot more beyond that. We're just going to explore it in a few different scenarios, and then that's our goal. So, example 1. Describe the transformation or transformations you could use to move the pre-image, the blue, onto the red figure, the image. So how would we get this onto this? Well, if I tried to translate, just slide it there and then down, I don't know if that would work. Because if I trace over this, and try to move that by just sliding it, if I slide it over and then down, well, translation won't work. So that didn't work. But you can kind of already see what was intended right here. If we rotate this around this point, this shape will end up exactly on top of that one. And so the transformation that we can use is a rotation around point P. And that's what will accomplish the transformation. Are we okay with that? Any questions about that? I mean, compared to stuff we've been studying, this is pretty simplistic. What about part B? Well, you can already see in the diagram what was intended. We can translate, which means slide, and then reflect over here, which is flip it. So in this case, we would have to do a translation, then a reflection. Any questions about that? Any concerns? Okay. So, see if you can interpret this yourself. You don't have to copy anything except, of course, you need to write checkpoint 1. And tell me what transformations would work to get the pre-image onto the image. The pre-image is here and the image is here. And same thing with B. Pre-image is here, the image is here. Okay, so take a minute. Bless you. up if you were able to write down transformations that would work for these situations. Good, put your thumbs down. Matthew, what'd you put for part A?
Translation and rotation.
Translation and rotation. Give me a thumbs up if you agree with his assessment. Translation and then a rotation. Is there any other way to do it? Okay, we'll come back to that. Part B. What'd you put? Kamoy and then Nathaniel. Kamoy, what'd you put? What? You agree with that, Nathaniel?
Yes.
So it was a translation and then a reflection. Well, let me ask you something. Let's go back to part A. Could we have done a rotation and then a translation?
Yes.
What do you think? Could we have flip-flopped it? Could we have done this first and that second? Think about it for a moment, and then I'll survey the class. The question is, could you do the rotation and then the translation? So give me a thumbs up if you think we could flip the actions around. Some of you think we could, and some of you don't. Okay, we'll see in a few minutes. What about part B? You think we could have reflected it first and then done the translation? What do you think? Eric, you think we could reflect it and then do the translation in part B?
Yes.
You think so?
Yes.
John, what do you think? You think we could? No, I'm not sure. We'll find out in a couple minutes. Are there any comments, questions other than what I was talking about? Something that's not clicking for you? Okay, so now example 2, I want you to take the slip that I gave you, write example 2 of course, take the slip I gave you, and I want you to staple it in. But do not staple onto either of the shapes. Make sure you staple into the white area. And then I need you to look as soon as, and I mean it's going to take a few minutes to get the stapler around. Don't worry about stapling, it's not a big deal. I just don't want you to lose it. So now just pause for a second and look up here. So just pause for a second, Sharik. Just put it down. Sharik. Just put it down for a second. This is called patty paper. Make sure you're looking up here. And we use it as tracing paper. So I'm going to give each one of you one of these, and we're going to use this to experiment a little bit, okay? But first, let me tell you what the goal is. Using transformations, explain why figure A and figure B are not congruent. So I want to know, why are they not congruent? Now, I'm looking at them, and to me, they look like they are congruent. But for them to be congruent, we have to be able to use rigid motions to get one to go exactly on top of the other. So your job is going to be to figure out why it can't happen. So here's what you're going to do. You're going to take the patty paper and you're going to put it exactly on top of shape A. You're going to hold it tight and you're going to use your pencil and you are going to trace exactly shape A. You should be able to do it freehand, although if you have a shaky hand, take the ruler and use the ruler. You should have a pretty perfect rendition of A. After you've traced it, then you need to take the patty paper and use it to try and figure out how to get this to flip or rotate or translate onto this. And see if you can do it. Any questions on what you're going to do? All right? Take one sheet. All right? So, even though this is an example 2 where I often model, I'm not using it that way. Your job is to actually experiment. Try to figure out how to get A onto B, but you have to use the 3 transformations that we know of. Translation, reflection, or rotation. See if you can do it. Take 2 minutes.
Write down.
Translation.
Yeah, then I don't get it.
They would both be in the same position. They would both be in the same position.
We'll both be like,
No, it's not a reflection, it's a rotation and a translation.
rotation and translation.
It wouldn't work either way.
Wait, can it,
No, you can't.
okay. Let's make it. So we write it down, right?
Same.
It's bubble paper. Bubble paper.
What?
Back in 6th grade, we were drawing something. Remember something?
Yeah.
Like she had some of this paper, and like, we just like draw, and then like, Sophie called it bubble paper. That is She's like, no.
So, let's come up.
Yeah. I tried. So dumb.
Okay, with the cool kids.
It's hard.
Is this what the cool kids
Why not?
are?
Make a perfect game.
But not for grades.
Oh my god.
Okay. Okay, well, I can end the time. I feel like a lot of us have stopped already. So, I phrased the question in a strange way, so I basically already told you that they're not congruent, but the question is why? Why are they not congruent? So what were you not able to do? Xiomara, what couldn't you do? No matter what rigid motions you did, you couldn't do it. So what you should have done, and here's my patty paper, so I cheat a little bit and I use the power of the computer. So if I try to translate this, I can't just translate it, that won't work. And so if I try to rotate it somehow, I can try that. So let's see, if I rotate it, I don't know, maybe like that? I don't know, will that work? No, that doesn't. So I can't translate it and rotate it, that didn't work, so let me go back. So what about reflection? Maybe it looks like I could reflect it, right? So let me reflect mine. So you should have done something like this, if it will cooperate, and flip in the x-axis. And so I flipped it over, and let's see if I can fit it on now. And, well, it looks like 2 of the sides are congruent, but one of these angles is not the same, and these sides are not the same. And so I was not able to use, and we were not able to use rigid motions to get it to go from there to there. It won't work no matter what we do. And so that is why these are not congruent. Does anyone have any questions about that? You tell me, what's the reason? You could not use any rigid motions to transform. Okay, very good, Zumar. Now, we're going to do a checkpoint to finish the lesson, but before we do, I want to talk briefly about the patty paper. This is a really good way of experimenting. So, if at any point we're doing something that involves a figure on a piece of paper that you need to try and either mentally or somehow physically transform or view somewhere else, and you would like to use a piece of patty paper, just ask me. This had, when it was given to me, it was about 2/3 full, and it was 1,000 sheets. So there's got to be about 600 sheets of patty paper. So I got plenty of this, and it's not expensive. I could get more. So this is a great tool to use. Okay? I'm not going to give it to you to take home to do the homework. If you need to do something at home, you could either see if you have tracing paper at home, or normal notebook paper is actually slightly translucent. So if you try to hold it up to the light, like if you wanted to trace over this, then you could actually hold it up to the light a little bit, and you could actually trace over it right onto your paper. I think the patty paper is a little bit nicer, and you can then move it around. It's also a little smaller. But if you don't have any, use your notebook paper. You might need to, okay? Any questions about that? All right, so checkpoint number 2. Here you go. Tell whether rigid motion or motions can move figure A onto figure B, and explain why or why not. Okay? You got 2 minutes.
Can you bring something out?
It's your work for me.
No, we both did. Y'all killing is like bees like cancel each other out. That's how you do that. When you come up to the day and capture.
I was wondering how people can be wrong.
I guess it's 'cause, like, say like you wrap somebody up, like the camera.
Okay. Can we use rigid motion to get figure A onto figure B? What do you think? Got Sharik, Nathaniel, and then we'll go to Alexandra. Sharik? No.
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 No,
No. Okay, why? Why, Alexandra?
the shapes aren't congruent.
They're not congruent. Okay, how do you know?
Because B is bigger than A.
How do you know?
It's like, if you, well, I didn't measure them. By like you like measure the distance from like the side.
Okay, but you said you didn't measure it, so how do you know for sure? Oh, you actually do know, but
Well, I
you
mean,
just...
I don't, like, I didn't do it, so like, I just like, used my head.
Okay, but there is a reason. Kadir?
Do you see like the bottom one, like the bottom line for each, like the slope is like different, like that's like 1/3, and that's negative.
Okay, so if you compare the slopes of this line and this line, you can already tell that there's a difference. Let me ask you this. Are there any parts of the two triangles that are congruent? Are there any parts of the two triangles that are congruent? Xiomara?
Yes.
What part? Okay, so the vertical line that constitutes this side and this side. So we could do a reflection, and this side would end up right on top of here. But if you follow what Kadir said, if you check the slopes, what allows you to check the slope? Like, how did he know the slope? Like, is he super math genius? How did he get the slope? Well, he is, but not because of this. How did he get that, Kamoy?
He counted.
Counted what?
From that point there,
But how did he count them? Count what?
you got to find the next.
Right, but you counted what? Is a simple word I'm looking for that eluded Alexandra. Yeah, the grid. He counted the grid. 3 over, 1 up. 2 over, 1 up. You count the grid. The grid is what makes it easy to tell. So I was waiting for Alexandra to say, oh, well, I can look at the grid and see. There's another way to see. Rigid motion preserves area. Look at the area of the two shapes. You can see it. It's got 2 full squares and then parts of these other squares. This has 2 full, 3 full squares here and here. And then most of this one, most of this one. You can clearly see the area is more in triangle B. So that's another reason why they're not congruent. Okay? And so there was a whole bunch of different things you could have said. You could say no, the reflection would only map part of it. You could say that the areas were different. You could do what Kadir said, that the slopes were different. A lot of different things you could say. But at the most basic, you need to be able to understand that no, they cannot be moved one onto the other. Any questions about that? Any concerns? Any issues at all with anything? Okay, draw a line across your paper. Your homework tonight is page 218, numbers 3 through 17, number 20, and then number 22 to 24. That's a total of 19 points. And in this case, it's actually 19 questions. There is no proof. You are going to have a quiz soon, but next week's schedule is a bit kind of, there's a lot of interruptions on Tuesday and on Thursday, so I will tell you when your quiz will be next week.